Hi everyone, welcome back to our series. Hope you are doing good. This is Mahesh. In this video, we will learn about two-sum problem, which is a lead code problem number 1. So this is a very famous uh, problem which is being asked in many companies. So let us try to understand the statement of this particular problem. So given an array of integers nums and an integer target, return indices of two numbers such that they add up to the target. Okay, so you may assume that each input would have exactly one solution and you may not use the same element twice. So you can return the answer in any order. Okay, so they have given few examples, and also let us try to see the constraint. So if you see, the length of nums array will be between 2 and 10 raised to 4. So there will be minimum 2 elements in the array. Okay, and if you see, the value in the nums array, it ranges from anywhere between 10 raised to minus 10 raised to 9 to plus 10 raised to 9, and also target will be anywhere between minus 10 raised to 9 to 10 raised to 9. Only one valid answer exists. So this is a constraint that we need to keep in mind. Okay, so with this, let us try to switch to editor mode and try to understand this problem. Okay, so as usual, these are the steps that we follow throughout this RE series so that we will be well prepared for the interview. Okay, so with that, let us start. So here, what this problem states. So basically, we will be given this particular nums array and we will be given some target. Okay, so this target value is nothing but sum of any two values that are given in this particular array. If you see, target is 9. If you add up 2 and 7, so it's equivalent to 9. So we need to return index of these two. So basically 0 and 1. So also we understood the constraints, right? For sure there will be one pair, such pair that gives the target, and you can return this values, the indexes in any order. So it accepts even if you change the order of the indexes of the answer. Okay, so with that, maybe what you can do, you can pause for a second and you can think for any possible solution. Okay, now let us try to understand what is the idea or intuition behind the interviewer asking this question to you. So basically they want to see you how effectively you use the hash map. Okay, hash map. So they are willing to check how effectively you use the hash map. Okay, so with that, let us try to see the brute force solution for this one. So in this case, what I will do, so I will put a reference point and then I will iterate over all the elements. Okay, and then I will try to sum up and I will see whether it gives us this particular target. Okay, let's do that. So 2, 7, 1, sorry, it is 11, then this is 15. Okay, now what I will do, I will start from here. Okay, then I will iterate over each element and I will sum up those values and see if it is equivalent to my target. So here what happens, here I will start with 2, then I'll iterate from this position. So it means 2 plus 7 equal to 9. So here in this case it is giving us properly the target in the first iteration itself. Let us assume the value is 26. So target is 26. Okay, in that case, how I will do? I will start with 2. So I will add up with 7 and I'll see it is 9. Then it is not equal to target. Then I will add up with 11. So it is 13. Again, it is not equal to target. Okay. Then 2 plus 15, it becomes 70. So none of these values are equivalent to target. Now what I will do, I will move to the next number now, that is 7. So then I will iterate over remaining numbers. So 7, then add 11, it gives 18. Again, it is not equivalent to target. Then 7 plus 15, it is equal to 22. Again, it is not equal to target. Now let us move to the next number. Let's start with 11. Now I will add up 15 and I'll get 26. Correct, right? So if this is the case, my target will be 26. So I can return these two indexes. So basically this is 0, 1, 2 and 3. So I can return 2, 3. Okay, so this is how, with a brute force, we will try to find the target. Okay, let us try to write the pseudocode for that. So what I will do, I will use for loop for I equal to 0, I less than n. So n will be length of nums array, then I plus plus. Okay, then what I will do, I will iterate over for j equal to, now it should be I plus 1. Okay, why I plus 1? There is no point in checking the previous values, right? So we can start with the I plus 1. Then j less than n j plus plus. Okay, so now what you can do, you can find the sum, or you can simply use if nums of I plus nums of j, if it is equivalent to target, then simply return I comma j. Okay, this is basically array of indexes. Okay, this way we will be able to find the target. Let us do a small modification here. We will use the same thing. So now what I will do, instead of adding and checking, I will try to find the complement. Complement in the sense, if my target is 9, this is my target, and if number, that is from the first loop, if I am trying to search with 2, what is its pair, then what I will do, I will search for 9 minus 2, which is 7. So this 7 is a complement for this 2 to become the total target. So now what I will do, I will use these two loops. Okay, I'll tell you why I'm doing this way. So before this particular loop, first what I will do, I will take a variable complement equal to target minus nums of I. Okay, so this will give us the complement, this value. Okay, now what I will do, I will do the linear search using this particular loop. So what I will say, if nums of j, if it is equivalent to complement, then I found my pair, then I can simply return I comma j. Okay, so there is a small modification. Instead of adding them and checking with the target, what I am doing, I am trying to find the complement, basically the difference, then I will try to search it with the remaining elements. So it is simple search in the remaining elements. Okay, so with that, now if you see what is its time complexity, what is the time complexity now? It iterates from almost 0 to n, and for each value, this is n, for each value it iterates almost n minus 1 values. So n minus 1, n minus 2, something like that. So somewhere it is close to order of n square. Okay, this is order of n square. Now if you see the space complexity, it is of order 1 because we are not using anything extra here. Okay, so that is clear, right? This is order n square solution. But is there any better way? So let us try to find that. So here what we are trying to do, we are trying to search for the complement value, right? So basically we are doing the linear search here. We are doing the linear search. So linear search will always be of order n, correct, right? So if we try to change this to order 1, then our entire solution becomes of order n. Okay. So how we can do that? So let's try to use the hash map. Let us try to use the hash map way. Okay. So now what I will do, I will let me take this particular array. So 2, 7, 11, 15, 2, 7, 11, 15. Okay. I will change the target this time. I will simply say my target will be 26. So now what I will do, I will take a hash map. Maybe assume this is a hash map. Okay. Now let's see. First, I will iterate over all the elements and I will try to store its index value because we are interested in taking the index, right? So 2 and its index is 0. We have 2 and its index is 0. Then 7, its index is 1. 11, its index is 2. 15, its index is 3. Why we are using hash map? Because the search in hash map is of order 1. Search in hash map is of order 1. So I will use the previous logic. So once after this, what I will do, I will start from this number and I will check what is its complement. Now if 2 is the number, then its complement will be 24. I will check if it is present here in this particular hash map. If that is the case, then we got the pair. Then we will simply return this index, basically this index and the whatever the index we get in the hash map. Okay. But one thing what we need to take care here is this index and whatever number we are searching for, that number, I mean, if assume we have target 6 and we have number 3 in the array, so its complement will be 3 only, right? So if that is the case, it should not look for the same 3. So we also need to check its index should not be equal to whatever the index we are considering at that moment. So we will check that in the code. So now what I will do, I will check for its complement. Is it there in the hash map? No, it is not there. So I'll move to next number. So if 7, then its complement will be now 19. Correct, right? Is 19 there in the hash map? No, right? So it is not there. Now I'll move to next number, 11. So when I reach 11, its complement will be minus 11 equal to, so 1, 5. So it is 15. Now if you see, we get complement in the hash map. So now its index is 2. Correct, right? This is the number where we are searching and its complement is 3. Complement's index is 3. We can simply return this. So now if you see, we have boiled down its time complexity to order 2n. Order 2n. How? One time we iterated over the array and we stored elements into the hash map. Then second time we again iterated and we checked for the complement, and then whenever we found the complement, that time we returned the value. So it we get the target or the indexes in 2 passes. And again here we are using extra space, which is hash map. So space complexity is order n. Space complexity is order n. Okay, let us try to write the pseudocode for that. So I will say hash map. So in Java, you can simply use map or object. So I will pass integer, comma integer, something like this. Then this is a map equal to new hash map. Okay. In JavaScript, it is simply new map. Okay. Now with that, let's iterate I equal to 0, I less than n. Again, n is length of nums array, I plus plus. Then what I will do, I will say map dot set in JavaScript and put in Java. So with that, what I will do, I will say nums of I comma value will be its index. Okay, that's what we stored, right? So this is first for loop. Next, what I will do, for loop I equal to 0, I less than n, I plus plus. Okay, now what I will do, I will say my complement equal to target minus nums of I. Okay, this way I will find my complement, and after that what I will do, I will check if my map has or contains key or contains key. So I will pass the complement. Okay, I will check if we have this value, and also and then I should not be equal to our map dot get of complement. So this will make sure it is not comparing it with itself. Okay, so if that is the case, I have found my pair. So what I will do, I will return I comma map dot get of complement. Okay, so this is one index, and the index of the complement will be given by the map. This way we return and we can close the loop. And we have seen its time complexity is order 2n and space complexity is of order n. Okay, so with that, let us try to execute this and see. Okay, let us create a hash map of integer comma integer. Okay, let's call it as map equal to new hash map. Okay, now what I will do, I will iterate for int I equal to 0, I less than nums dot length I plus plus. Okay, what I will say, map dot put of nums of I comma value as I, because we want to store the number as element and its index as value. So this is our first pass. Next, in the again second pass, for int I equal to 0, I less than nums dot length I plus plus. Now what I will do, I will first find the complement. Complement will be target minus nums of I. Okay, now what I will do, I will check if my map dot contains key. I will pass my complement. I will check if my complement exists in the map, and also map dot get of complement should not be equal to our I. It means it verifies we are not comparing with the same number. Then if that is the case, I will simply return new int. Okay, then I will pass I comma map dot get of. Okay, so at the end we will simply return -1. Ideally this statement never executes because there will be for sure the complement pair exists. So this will only give us the intended answer. So I will run this. Cannot be converted into int, so maybe I will say new in of something like this. Okay, so this got accepted. Let's submit. It got submitted successfully. The editor. Now, if you see, it is already optimal, right? O of 2n and O of n. This is time complexity, this is space complexity. Is there any way where we can improvise this to order n? Is it possible? Yes, let us see. Now, here what we are doing, we are first preparing our map, and then what we are doing, we are checking for the complement. Now, let us take the example again, which is 2, 7, 11, 15. 2, 7, 2, 7, 11, 15, and our target equal to 26. Okay, this example only. Now what I will do, I will try to implement it in single pass. So before what we did, we prepared first map, then we try to check the complement. Now what I will do, we will prepare the map, side by side we will also try to check the complement. Now what I will do, this is my map. Okay, I will start with this number. So if 2 is our number, what is the complement? Our complement will be 26 minus 2, which is 24. Okay, so if this is our map, does map contain 24? No, right? Then what I will do, I will simply push this 2 with its index and I'll move to next number. Then let us try to find the complement. So 26 minus 7 will become 19. Do we have 19 in the map? No, right? Then we will simply push 7 with its index. Then we will move to next number. Now I move to 11. And if you see the complement, it is 15. Correct, right? But according to us, 11 and 15 are the complements. So if that is the case, we expect something in the map, right? So we don't get the second number at the first go itself. So we will have to pass through the first number, then only on the second number occurrence we will get the first number. That's the beauty here. Okay, so if that is the case, now I don't find 15. So I will simply push my 11 with its index and I will move to next number. Now if you see, I am at 15. Now my complement will be 11. If it is 11, then we have 11 in the map. So if that is the case, then we will simply return this index 0, 1, 2, 3. Okay, and then we will get the value from the map. So from map it is 2, then from the iteration it is 3. So we will simply return this. So if you see, with one iteration only, what we did, we prepared map and also we try to find the complement. Okay, let us try to write the pseudocode for that. So again, hash map, this is the initialization. So now for I equal to 0, I less than n, I plus plus. Okay, now what I will do, I will first find the complement. Complement equal to target minus nums of I. Okay, now what I will do, I will check if my complement is there in the map. So map dot has or contains key, then we will pass complement. If it is there, then what we will do, we will return map dot get complement, okay, comma our index I. Okay, if that is not the case, we will simply add that value, map dot set or put in set in JavaScript, put in Java. Okay, then I will say nums of I comma I. Okay, so this is how we prepare the map. So this is simple and straightforward. So this is the most optimal one. If you see, with only one iteration, we find the pairs. Okay, so that's why it is of order n. This is time complexity, and space complexity is also order n because we use map. So this is the most optimal solution. Okay, let's execute this and see. I will comment this. Let's keep the map, and now what I will do, I will use for int I equal to 0, I less than nums dot length I plus plus I plus plus. Now what I will do, I will first find the complement. I will use this. Okay, now I will check if map contains key complement. If it is there in the map, then what I will do, I will simply return new int of. So what all I need? So map dot get of complement comma my I, index I. Okay, if that is not the case, then simply what I will do, I will say map dot put of our nums of I. Here we need to insert nums of I comma its index I. Okay, and I will uncomment this line so that, or I will okay, I will uncomment and I will run this. Okay, it is accepted. I will submit this. Okay, our solution got submitted successfully. So this is the most optimal solution for this two-sum problem. Hope you liked the explanation. If that is the case, please consider subscribing to my channel, and also like the video, share it with your friends, and also if you have any queries or any feedback or anything, maybe you can add that as a comment in the video. Thanks for watching the video.